Hi, welcome back to my series on the Racket programming language. Today, we're going to review the basics of let. Let is an important special form because we use it to introduce variables and their bindings. And so let is how you introduce local variables. And for those of you that are familiar with programming, using local variables is kind of a bread and butter of a programming language. So what I've done to demonstrate these is I've created three seemingly incorrect functions, and there's subtleties for why they're incorrect. But the thing that I want to note that's really interesting is that if I run this, the first thing that is popped up is that we have this unbound identifier in y. But this function here works completely fine. I've got no syntax errors here. And for those of you that are familiar with other languages, that's really strange because what I've done here is I've introduced a local variable x and assigned it to 1, but there's already a parameter called x. And in most languages, that's not allowed. You're not allowed to what's called shadow a parameter like that. And the reason being, of course, is obviously this is introduced a nasty little bug, in which if every time I call shadowed incorrect, it's just going to return 2, regardless of what I pass in there, because it's always going to set x to 1 and then just add 1 to 1. So that's why most languages disallow it. So the reason Racket doesn't is because of historical reasons. It goes back to how the language was originally defined, and it turned out removing this kind of shadowing made things a little bit overly complicated for the language and would reduce some code that actually kind of relied on this behavior. And so it's been kept in. And of course, there's tools around Racket that would potentially flag this as like, warning, you should really do this. This is ugly, but it's been allowed in. And the reasons kind of go back to how Lisp did scoping. And what scoping is basically scoping is the rules for if I have a variable here, how do I find out what its binding is? What does it mean? What does it refer to? And we are used to, in most programming languages, what is called lexical scoping, in which we have a very defined set of steps of how we move from the very bottom all the way to what is called like the global namespace in most languages, to find that value if it exists. Well, in Lisp, it did something different. In Lisp, part of what you do is you track the environment, and it does a set of frames. And the reason it's called frames is because it actually does relate to the stack. But I won't get into too much of the details of implementation. But what happened is that as you ran a program, it would introduce these frames. And if you wanted to look up a variable and its binding, you just moved through the frames from the very most recent all the way to the very top. And the first one you found is the one that you used. And they didn't put any more rules in there. And so they basically allowed this to happen because they wanted to make this kind of code to look up variables as simple as possible and as fast as humanly possible. And there's some interesting context around that. That kind of thing is called dynamic scoping, by the way, is that it also allowed for a very powerful set of programming ideas to come up in Lisp because you could really redefine how a function ran by introducing new bindings in where it was called to all sorts of things, not just the variables, but to like functions themselves. You could rewrite and intercept functions, do all sorts of very interesting stuff. And to be perfectly honest, it's one of those things that made Lisp probably maybe too powerful for its own good down the road. But it is an interesting part of understanding how Lisp was a very powerful and flexible language. There's a great book called Let Over Lambda, which really goes into some of these advanced usages of how you did this. And for those of you that are really interested in programming languages, it's worth looking up and trying to find that book. But this works in a Racket, even though it's not a very, very good pattern. So let's go look at the first incorrect one now. So the reason, again, I bring this up is that just be careful that you can introduce shadowing if you're not careful. And so to keep an eye out for it. The second one here is this is incorrect. And it's what it's done is it's complained that it doesn't know about what y is. And this is another thing that really trips people up because, well, I introduced this right here. And again, in most programming languages, this wouldn't be a problem. because lexical scope, these are in the same lexical scope. Now, again, what Racket is doing here is introduces a new frame. And the rules around looking up a variable mean you don't look inside the same frame for a variable binding. You kind of look all up. So it's looking outside this let body, this part here, let declaration, for a value of y. Now, of course, this is common enough that really doesn't make sense. And so what you can do is, if you want to say, actually, you know what, I want you to kind of make a new frame for every single variable introducing here, then you can do this, what's called let star. And if I run this, it should now bump up and complain about this as being an error down here. And we'll get to this later. But now this works. And the reason being is that I've introduced a frame here for y, and then now I've introduced a frame for z. And now I'll go ahead and look up in that in frame and find y and find it there. Now, from a practical standpoint, again, from the very beginning of Lisp, when it came out in the 50s and 60s, and even up to the early 70s, this kind of performance optimizations were important and did matter. Nowadays, modern compilers and interpreters are so good at managing the environment that these distinctions are much more about being correct. It's basically, this is saying, hey, did you really want to introduce and refer to things here, or did you want to go up to something up top? And this is probably where Racket trips up the most people, because it is kind of the opposite of what most programming languages do, but there's some good reasons for it. And the thing about it is that for the most part, there really is not any performance penalty right now for using let star. It's just that Racket wants to be able to be precise as possible about how you introduce variables. So it wants to make sure that you use let star and things very precisely. So it makes you really think about how you're introducing variables and you're binding them. And that's a good thing. The reason it really wants to be picky about this too, another main reason is that Racket has macros. It can define macros and how you do basically, you can take code and transform it into other code. And if you weren't very precise about how you introduce variable bindings, it'd make macros much more difficult to write. So that's another reason why they're very picky about how these things work. So the last one here, I have done, this one's a little bit more fancy. What I've done here is that I have now introduced a local variable list up to, but since we have higher order functions in Racket, I've bound it to a lambda expression. But of course, this lambda expression is recursive. And again, if you remember how let works, this should make sense because it doesn't know to look. When it looks for this, it's going to start looking in the frames above it. It's not going to look here, right? So one thing what might be to do is that you just go ahead and go let star, but that still doesn't fix it. And the reason being is that this lambda is the value or the binding of this variable, and let star is about future variables and having variables inside their binding. This is referring to it in the same level. So this, of course, is allowed, but what you need to do is you need to do something called let rec, and that rec stands for recursive. And so what this does is that this lets this thing to know that, okay, define this in a way such that it can be referred to in the binding to which that variable is introduced. So it knows to be able to set that up properly. And again, it wants you to do this explicitly to make sure, did you really want this to be a recursive call? And so if we run this, now we should be able to run all these programs. And if I do the right thing here, I can show you that shadowed incorrect indeed does not work like some people would expect. It always returns 2. I can see now that let incorrect 2, 4 now does something. And there we are. So being very aware of these let forms, let star, and let rec, is kind of going to be the thing that when you get more into Racket, or if you get into Racket more as a programming language, will really help you become more proficient with the language. And it also has a value in terms of teaching because it really makes you think about how you're managing what's called the environment. And that's a really good way of having to understand programming languages in an abstract way versus how they run on a machine, is basically to understand how something is evaluated in an environment. And we will get into later on down the road into how you can explicitly create a data structure to mimic what an environment is in Racket itself, to show more about how you can really make these ideas of variable lookup much more explicit. But that's further on down the road. Anyway, thanks for watching. If you've enjoyed this video, please do like and subscribe, and I will see you in the next video.